Now, Chapter 10, Straight Lines. You know, a plane or a Cartesian plane. Cartesian plane means the plane with two axes, coordinate axes, x-axis and y-axis. X-axis usually the horizontal axis drawn horizontally, and y-axis is the perpendicular axis, perpendicular to the x-axis. And these two axes are number lines. The point representing zeros of the two lines will be coinciding. And also we know these two axes divides the whole space into four quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant. And also every point in the plane will have two coordinates with respect to these two axes. With respect to the x-axis there is an x-coordinate, and with respect to the y-axis there is a y-coordinate. And if x and y are the coordinates of a point, then it is usually denoted by xy within a bracket, that we know. So we may consider the x-axis and the y-axis. So x-axis the horizontal axis, y-axis the perpendicular axis. So the 0 is point representing 0, 0. 0, 0 means the x-coordinate of this point is 0, y-coordinate also 0. Everything you know, you are quite familiar with this. Just a review. If P is xy in the plane with the coordinates xy, we denote this by writing like this: xy within bracket, first x-coordinate and the second y-coordinate. So this x-coordinate is x means it is the perpendicular distance of the point, or the shortest distance of the point from the y-axis. That is, this is the distance. This is perpendicular to the y-axis. So this distance is x. And this y-coordinate, y means it is the shortest distance, the perpendicular distance from the x-axis. So this is y. This length is y. This is y. Or in other words, we can see that the x-coordinate is the distance of the foot of the perpendicular from the point on the x-axis from the origin. This distance of the foot of the perpendicular from the point to the x-axis from this origin. This distance is x. Similarly, the y-coordinate is the distance of the foot of the perpendicular from this origin, foot of the perpendicular on the y-axis from this origin. So this is x and this is y. And similarly, every point in the plane will have such coordinates. Every point, or every pair of numbers x, y will be represented by a point in the coordinate plane. Every pair of values like this, xy like this, xy, every pair will be represented by a point in the coordinate plane, or every point in the plane will have such two coordinates, x coordinate and y coordinate. Okay, and again in the plane, in the coordinate plane, we can have various figures, diagrams, etc. We can have a figure, say a line segment in the plane, say a line segment like this in the plane, or a full line in the plane extending to about infinity, a line. We can have a circle in the plane. A circle. Or we can have a parabola like this. Or like this. We can have ellipse. Different figures. We can have those in a given plane. These figures can be considered as collection of points in the plane in such a form. In such a form. This line segment is the collection of points with these two end points in a continuous way without any gap in between. Circle is also continuous collection of points in the circular form. In the circular form. With the certain, of course, specifications. We have different circles. Circles with a smaller radius, larger radius. So that will be depending upon how we choose this collection. That means the collection of points taken in a certain specific form, specific way. We usually refer the specific way as collection of points with certain conditions. Anyway, we will come to that later. Similarly, this parabola, collection of points. This straight line as a whole, collection of points, points in a continuous way, in a straight way also. So every such a figure can be considered as collection of certain points in the plane. Or in other words, we can consider this in some other way also. A line, for example, we will be discussing the details of straight line in this chapter. So a line can be considered as the path of a moving point in a straight way. We can consider in that way also. That is, we choose a point, there is a point on the line. And this is, or there is a point in the plane, of course, a plane. Then the line is the path of the point. We assume this point is moving in a straight way. Then the path, so this is the path of the moving point as the straight line. In that way we can consider. This path is also known as the locus of the point, moving point. The path travelled by the point, the locus, the path. In that way we can consider. Anyhow, we consider this curves or this figures, diagrams, etc. in that way, collection of points. And also, when we discuss the details of the line, we need additional information of this line. A line can be in different forms, different lines. So, this is a line, this is a line, this is also a line. Different forms. Some lines can be horizontal lines. Horizontal means parallel to this x-axis. So this is a horizontal line, this is also horizontal. In that way we can have different horizontal lines, infinitely many horizontal lines. So lines can be horizontal line or vertical, parallel to this y-axis, vertical, or inclined like this. Inclined means inclined to the axis. Usually the inclined line is considered as the line inclined to the x-axis. Of course it is inclined to both the axes, but we consider the inclination of the line with the x-axis for details and or for getting more information of the line. So if the line makes a certain angle with the x-axis, we can see that there are two angles. One angle made by the line with the positive direction of the x-axis. Suppose if this is the line, then this angle, the line angle made by the line with the positive direction of the x-axis, and then the next, the remaining 180 minus theta, 180 minus theta. If theta is your Then the next angle, the supplementary angle. So two angles. Usually by the angle made by a line with the x-axis means the angle made with the positive direction of the x-axis. This angle. The angle made by the line with the positive direction of the x-axis. And if we know this angle O, if we can have a measurement for this inclination, we will be having a picture, an idea of the line, how the line is drawn on the plane, or how the line lies on the plane. So we will have a value, or we will have a measurement for this inclination. Inclination means the slope. So the measurement is known as the measurement for the slope of the line. And also we will discuss equation of straight lines. How we can represent a line algebraically. Geometrically we represent by drawing this diagram, but algebraically how can we represent? It is an expression, mathematical expression with which we can represent a line. We will discuss the details later. So in that way we can have varying results of this lines in this chapter. So we need before that certain additional results which you have already seen earlier. And after discussing this with this idea in mind, we will go to the slope and also the equation of the line in the next videos. Okay.